Okay, so still on the economics. Right now, let's look at some of the cost index problem that we can actually have, right? So for a cost index, right, if I want to actually calculate for a cost, right, in a certain year, right, that one will be equal to the cost in the base year, right, multiply by the cost index in the year that I want to evaluate the cost, divided by the cost index of the base year, multiplied by the R, right, which is the capacity ratio, right? So the R is the capacity ratio. You get it here. So that's actually everything about the cost index. So based on this approach, right, you'll be using this one to solve some questions, right? So they can ask you to use we have some methods that we have. They can ask you to assume M&S, right? Marshall and Swift to at equipment index, right? They can also for process at industry. We also have others over there, right? So let's see how to evaluate. So the first question says that the purchase cost of a tubular heat exchanger, carbon steel shell, stainless steel tubes, and a heat transfer of what 400 right meter squared, right? So the area in 1968 is what 400 what meter squared, right? And so if the area is this one, meaning that they told us that um the cost, right? So the cost in 19 right 68 is $60,000, right? That was in January, right? And we used a similar one, right? Which was being used in 1978, right? So the area is also 978, is also be 400. So that gives us a capacity ratio of 1, right? From this question. And from here, we have to get our index, right? So the index. But the question said that we should, what is the percentage increase in cost from 1968 to 1999? If the inflation rate, they give us an inflation rate from 78 to 99, right? So basically, that's what we want to use to solve this question, right? So first of all, let's approach this question. So we have the cost in 1968 to be $60, $60,000, right? So let's look at the index for 1968. Then we look at the index for 1978 too. Right? As I said, we're using the Swift, Marshall and Swift, right? So Marshall and Swift over here for process. So this is the Marshall and Swift, right? So this is the Marshall and Swift. So for process industry for 1968, right? For 1968, we have a value of 268. And for 1978, we have a value of 554, right? So that's what we are coming to use over here. Right? So for this one, I have a value of 268. Then this one I have 554. Right, so if I want to calculate the cost in 1978, which is the year, right, so the cost of what the base year, which is 1968, times the index, right, of the year, I want to find my cost, divided by index of what the base year, then times the R, right. So over here, this one is 60,000 multiplied by 554 over 268 multiplied by 1. Yeah, so I told you the capacity, right? So the capacity ratio is 1. So this gives us a cost of 124,029.85, right? Dollars. Right. So this is the cost in 1978, but they want us to calculate the increase, right? The percent increase from 68 to 99. That's why they gave us what an inflation over there. So if I want to actually get the cost in 1999, it becomes the cost in 1978 plus the inflation rate multiplied by the cost in 1978, right? This is basically what we wanted to calculate, but without getting the cost in 1978, we couldn't have calculated for the cost in 1999. That's why we had to calculate for cost in 1978 before. Right, so this one we have so it will be um for 029.85, then 1 plus 0.03, right? So this one, if you factorize it out, you get 1 plus 0.03. So the because the inflation rate was 3%, so 0.03. So this gives us a cost 1999 to be $750.75, right? So right now I can actually calculate for my percentage increase, right? So the percentage increase becomes 127750.75, right? That's the cost in 99 minus the cost in say 68. You get it, which is 60,000 divided by the 60,000, right? They said a percentage, right? So times 100. So this gives me 112.9 what percent, right? So this one, the cost index, right? The question wanted us to calculate the increase from 68 to 99, but 68 to 99, but they gave us the inflation rate for 78 to 99. But we need the cost for 78 before you can do it. So we use the cost index approach to get the cost in 99, the cost is 78. Then that can help us to get the cost in 99. Then we can actually evaluate what the cost out index, right? Yes, that's it. So let's see question two, right? So for question two, they said that the purchase costs of a 1,200 liter stainless steel tank. So the cost in 1965 is $15,000. So the tank is a cylindrical with a flat top and bottom with a diameter, right? So the diameter is 3 feet, then with a height of 6 feet. If the entire surface of the is covered with 2-inch thickness of magnesium block, estimate the total equipment cost plus the installed insulated tank in 1970. So right, on the cost. So we are dealing with 1965 and 1960. So that means that we need the cost index for those two, right? Yeah. So the purchase equipment cost, right, the total becomes for just the equipment plus what the installation cost, right? So that's what we want to actually calculate for. And so if I want to calculate the purchase cost of the equipment, right? That is the cost in 1970, right? It will be equal to the cost 1965, which is the base year, times the index in 1970 over 1965 times what the R. But the R is 1, right? The cost in 1965 is 15,000, right? And they told us to use MNS, right? So MNS for 99, 1970 and 1965, right? So as you can see over here, 1960, right? 1965. 1965 is 244. Then 1970 is what? 301, right? So that's what I can to use. So over here I'll have 301 divided by 244 times 1. We use the same equipment, so the capacity ratio is 1. So this gives me 18,504 to $1, right? So I have this amount. So that gives me the cost in what? 1970, right? Which is the purchase cost of the equipment in 1970. You get it? So over here you can see that the installation cost, right, consists of the we have um the block, right? The block cost, right? So they said the magnesia block, right? Then we had the magnesia block. So we have the LC plus the BC, right? Where we can actually calculate for both of them, right? So you can have the total surface area, right? So the TSC, right, becomes pi d squared divided by 2 plus the pi dh, right? So that's the total surface area for the thing we are considering. And we have the so we have pi 3 squared divided by 2 plus pi times 3 times 6. So this gives me 70.6858 feet squared because it's an area, total surface area. So that gives me the installation cost, right? So the installation cost becomes, so they said that we have the magnesia block was $4 per feet squared. Then the labor, so that's the labor cost over here, right? So that one too was also at 2, right? So we can actually add them. So you have 2 plus what 4, which gives us the $6 per feet squared, right? So that one multiplied by the 70.658 actually gives us the installation cost, right? Which becomes $424.11, right? So if we get this one, then we can go back to this formula. Since we have the purchase cost of the equipment to be 18504.1, then we add that one to the installation cost, which is 424.11. Right, so this gives us $18,928.21, right? So this is actually the cost, right? This is actually the cost, right? So they asked us to calculate the total equipment cost plus the installation cost. So this is the equipment cost was this one, installation cost was this one. So the total we add the two, then we get the cost over here. So that's number two, right? So let's solve another question, which is the fourth question, right? But the fourth question said that the purchase cost of a shell of the tube heat exchanger, carbon shell, stainless steel tubes, and heat transfer of 600, right? Was this in 1999? So the cost in 1999 is 86,000, yeah, 86,000 euros, right? 6,000 euros. So you said that estimate the cost in 2006. Use the process engineering index, and they give us an right inflation. So the inflation from 2004 to 2006, right, is 2.5% each year. And so from 204 to '05 to '06 to '05 is 2.5 to '06 is also 2.55%. Right? So let's see. This one, I'm using the process engineering index. You're not using the Marshall Institute, right? So for the process index, right, this is what we do. So we know that the so if I want to, so we are starting from 99, right? So the index in 99, then the index in 2000. Let's see why we are doing the 2001. If we check for this graph, this is the process engineering index, right? The first one, that's the process engineering index, right? If you can see the process engineering index, you can see that there's a um, there's no continuation from 2000. You see, this one ends at 2000, then this one continues from 2000. So actually, you have to calculate from 2000. You have to calculate from the base year, that's 98 to 2000. Then we take it from 2000 to wherever we want to get. So that's why we are taking the index for 98 and for 2000, so that I can use that one to solve. So for 98, right? 1998, the index is I'm sorry, for 98, the index over there, right? 1998, the index there is like 106 if you read from the graph over here. Then for 2000, right? Since we are using the first one, the index there is like 108 from here, right? So based on this one, the index for this one is 106, then this one is 108. So that can help us to actually calculate for the cost in what 2000 using a cost index formula. So the cost in 1998 times the index in 2000 over the index in 1998 times 1, right? That's the capacity ratio. We have 86,000 times 108 over 106 times 1. So this gives us 87622.64 euros. Alright. So we have this one, right? So that's the cost in 2000. Right? So you can also use the same approach. Since you have the cost in 2000, you can get the cost in 2004. That one becomes very easy to do. Right? Because we can't just move from 98 to 2004 because of that discontinuation from the graph over there, right? So over here, the cost in 2004 using 2000 as the base year becomes 87622.64 times, so the index at for 2004 is 111, then for 2000 is 100 from the process engineering index graph, right? So this graph over here, I see if I read 2004, so this is 2004, so reading that value over there is 111, Then 2000. Right now, we use this one since you are moving from here to here. So we use the second one, which is what? 100. Right. So over there, then, so times 1, that's the capacity. So the cost in 2004 gives me 97 to 61.13 euros, right? So since I have this cost, that means that I can also calculate the cost for 2005 since I have the inflation rate, right? So the inflation rate, so cost in 2005 becomes the costs in 2004, which is the 97261.13, then 1 plus the inflation rate, which is 0.025, that's the 2.5%. Right, so this gives me 99692.66. Right, then from there, since I also have the inflation rate should also be 2.5, I can also move from here to from 2005 to 2006, right? So 99692.66. This one's also 1 plus 0.025, right? So this gives me 1021814.98 euros, right? So so they want us to estimate the cost in 2006, but we can't estimate from 1998 to 2006 straight away because of that discontinuity in that graph, right? So you have to estimate first 2000, then we estimate 2004, then getting 2004, we can use that one to estimate 2005 since you have the inflation. Then that can also help us to get 2000 and 2006, right? Since we have that one, yes. So now let's move to the next question. Right, so let's move to the next question. The next question over here is the second question that we have over here. Right, so is the second question that we have over here. They said that we should they want us to calculate the total capital investment, right? So what we know over here is that the total capital investment is the TCI, right? Comprises of what we call the FCI, and it comprises of what we call the FCI and the working capital, right? Which is the fixed capital investment and the working capital. The working capital is a percentage of the fixed capital investment, or sometimes it's a percentage of the total capital investment. So it depends on which one the question is talking about. Please, you have to be very observant, right? You have to be very, very observant. And the fixed capital investment also has what you call the direct cost and the what indirect cost, right? And they all have some factors that's what they depend on, right? They all have some factors that they depend on. So you have to be very, 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 very so the direct cost, right, has this formula that we call the purchase cost times 1 plus the factors from F1 to let's see F9. Yes, then we have the indirect cost, right, which becomes the direct cost, then the factors, let's say from 10 to 12, right? So these are the formulas that you come to use to solve this question, right? Then based on this question, we can use a graph, right? So there's a graph that we use to estimate. So if you have an absorption column, right, the way to evaluate is purchase cost, right? And we have a way to also estimate the cost of the parkings. If we have a recovery column to the same thing, but that one we use a sieve. Then a distillation column, right? For distillation, you can have a red boiler, cost of a red boiler, and you can also have a recycle solvent cooler. They all have a way in the cost of even the tanks, right? So if you can see this graph, this graph is for the vessel. So if you have an absorption column and those columns, right? We use this vessel. So you use the vessel height against the diameter. Right. So if the diameter is 1 meter, then that means you are using number 2. But it depends on whether you're using dollar or you're using pounds, right? So any of them. So you use the vessel height against that one, right? Then the next one over here is for the plates. When you're using plate. So that one too is the plate diameter against the type of plate, whether it's a sieve plate or a valve or a bubble cap, right? So that we can actually read the cost of it, right? Then we have this for the heat exchanges, right? So that one is the heat transfer area, right, against the type we are considering. So the type factors, whether it's a floating head or a U-tube or a kettle or a fixed tube sheet, like that one also depends on this one. And it also depends on the material type you are using, whether the shell is carbon steel, the tube is carbon steel. So if you have carbon steel, shell and tube, that means you are using number one. If you have carbon steel, brass tubes, we are using number two, like that in that way. And this one over here is when you are using we have a storage tank, right? So it's a cone roof. So this one we have a formula that we use that the formula we use over here. So the cost becomes the C S to the power n, right? Where this one is the capacity, right? And this one is the constant, right? And this one is the what? The index. So assuming we are using a cone roof, right? So if you are using a cone roof from here, you can see that the cone roof, the C, so let's say you are using dollars, so the C becomes what 2,300, which is over here. Right. Then the S is the capacity. So let's say it's the 35-meter cube um tank. Sorry, tank. So that's the S. Then this is the index 0.55, right? That's when, yeah. But if the thing is a stainless, which is a stainless steel, that means that the cost that you get, you have to multiply the cost by what 2.5. Very, very important, right? So that's basically everything. So let's see the question. So we have this question over here, right? So they told us that the working capital is 10% of the fixed capital investment. So this one is 10% of the FCI, right? So and they give us F1, they give us our factors. When they don't give you your factors, please you have to know where you're supposed to read your factors from, right? So when they don't give you your factors, right, you come here. So depending on whether you are considering a fluid, where is a gas or a liquid, or you are considering fluid solids, or you are considering just solids, depends on the type of factors that you'll be reading. So these 9 factors from F1 to F9 is for the direct cost, and the indirect cost is 10 to 12, right? But when you are doing a modification to a plant, you don't need a contractor's fee, right? When it's an existing plant, right? So that one goes out. But when in a given question they give you the factors, use the factors that was given in the question. But if they don't give you the factors, please, when you are reading your own factors, buildings and process, so you use just F1 to F4, right? When you are just doing modification, that's when you have an existing plant. When you are reading it yourself, but if in the question they give it to you, please use all the factors given in the question, right? Yeah, use all the factors given in the question. So if I check the question very well again, so I can draw a table where I have the equipment and I have the equipment cost, right? So I'll have the absorption column, right? So absorption column, they said the cost is 9,800. That's the column, right? And the parkings was 6,786. Right, so you're making everything in Ghana cities, right? So this one was that. Then we had a recovery column, right? Recovery column, that one too also cost 45,000 plus the 8,670. Then we had a distillation, right? Where we had 76,000 plus 4,800. Then we had a cooler, which is 2,550. Then we had a storage, right? Storage tank, where we had 7,790, right? So that's the cost of everything. So if I add everything, that gives me what the purchase cost of the equipment, right? That's 102,996, right? In Ghana cedis, right? So that's the total cost, right? And the direct cost is what we also call the plant physical cost, right? So PPC. That's also the direct cost. So the direct cost becomes 102,996. As I gave you in the formula. So one plus, right, the factors. So I told you that the direct cost factors, we have F1, so 0.4, we have F2, 0.7, we have F3, which is 0.2, then we have electrical, which is 0.1. Please, F5 over here, design and engineering and contingencies, they are indirect cost. The 5 and 6 there doesn't mean that it's a direct cost. Please take note of values very well. All right, so the direct cost gives us 247,190.4 Ghana cedis, right? And indirect cost, as I told you, is the direct cost into brackets, the factors we have. So over here we have just 5 plus 6, right? So this one we have 247,190.4. Then over here I'll have 0.3 plus what? 0.2. So that gives me an indirect cost of 123,595.20 Ghana cedis, right? And I told you that the fixed capital investment consists of the direct cost plus what? The indirect cost. So if I add the two, that gives me what? The fixed capital investment. So if I add the direct cost and indirect cost, I'll have 370,785.60 Ghana cedis, right? Yeah, so I have that one over there. Then they told me that the working capital, right? The working capital is 10%, right? So, but you can find the TCI to be what? FCI plus 10% of what? The FCI. That gives me the TCI. So the TCI becomes the FCI, which is 370,785.6 plus 10%, that's 0.1 times 370,785.6. So this gives me a total capital investment of 407,864.16. Right. So that's the total capital investment. So that's what the question asks us to what evaluate. So in a question that they don't give you the cost, you have to be using the graphs I showed you to be reading your costs. Right. So if let's say we are using the absorption column, let's say the vessel height is 10 meters, right? And the diameter is, let's say, 1 meter. So you are using number two. Right? So you are using, let's use dollars. So 10, then number two. So if you trace it over here, then you use, let's say we are getting, let's say 12, right? Let's say you are getting 12. So 12, but you can see over here that you have to actually multiply by this what? 1000. So the value actually is 12 times 1000, which gives me what? So it's 12 times 1000, which gives me 12,000. So that's actually the cost. And this cost is what you call the bare cost of the equipment, right? So if you want to actually get the purchase cost, right, is the bare cost multiplied by the material factor times the pressure factor. So let's say the material of construction is stainless steel. So you multiply the cost, the bare cost by 2.0. If it's carbon steel, you multiply by 1.0. Then if the pressure in which the system is working is 1 bar, we use 1.0. Right. If it's 5 bar, we use 1.1 over here. Right. If it's 20 bar, we use 1.2. So that gives you the purchase cost of the equipment. The one you read from the graph is just the bare cost of the equipment, right? So same thing for the recovery column, right? But this one is just for the column. But you know that the column two has packings. I mean, the absorption column has packings. That's what you have to so evaluate. So if we come over here, this one over here is for the plate, right? So if you have a sieve plate like the recovery column, so you have a sieve, you know the plate diameter. So you check um the the plate diameter, right? Let's say the plate diameter is 1, and then its type of sieve is a sieve, so it's 1. So you read the value over here. So if this one you read the value, it's actually that value that we're using. You see the over here, you don't multiply by what anything, right? You don't multiply by anything. Then this is for the heat transfer, so the heat exchanges. So you need the area in connection with the type of material used in construction. But now if you read over here, it's the bare cost. So if you multiply by the pressure factor and the type factors, that gives you the purchase cost of the equipment itself, right? Yes. Yes. So to this question, that's what they ask us to basically calculate for us. And sometimes the question, right, can be in such a way that, let's say, it can be that TCI will be equal to FCI plus, let's say, it will be 10% of what the TCI. Right. This one it was of the FCI, the first one. So if say what if it's of this one? So it will be like TCI will be equal to the fixed capital investment from this question, right? We got 370,785.6. right, plus, so this one to be like 0.1 of what? The FCI. Where we have to, sorry, the TCI. We are solving for TCI now. Right, so when it will be TCI minus 0.1 what TCI is equal to 370,785.6.6, right? So over here, I have to subtract. Yeah, I have to subtract the TCI because I'm finding the TCIs, right? So 1 minus 0.1 gives me 0.9, right? So if I have 0.9 of the TCI is equal to 370,785.6, right? So I'll have 370, nice, 785.6 divided by 0.1, right? So this gives me a TCI of 370,7856 as Ghana cedis, right? So this is when the working capital is a percentage of the total capital investment. But if it's a percentage of the fixed capital investment, now you also have to know how to go about it, right? So if you look at this question 3 like this, you see that they give say the diameter is 1 meter, vessel height is 15, then packed height is 12 meters, packings we have 25 millimeter, right? So that one too, we have a way to evaluate them. And here we have the packed height, right? So that one we use these values. We use this table over here. Yes, we use that one. So when we have the packings, we use this. So if it's a saddle packings, right? This is the cost. So whether you are considering, so let's say you are considering dollars, right? So it will be $1,400 per watt meter cube. So if you have the packings, you have to even calculate for the volume first, right? So whereby the volume is mostly pi d squared over 4 times h, right? They have the diameter, have the height. So you calculate for the volume. So when you get the cost per volume, you multiply the volume by the cost per volume to get the actual cost of what the packings. Before you add that one to the purchase cost of the absorption column to actually get what the cost, right? And over here you can see that a plant modification is being made, right? So you are making a modification to the plant. Since you're making a modification, that means it's an already existing plant. So if an already existing plant, meaning that the factors you'll be needing over here are just F1 to what F4. Then we need F10 and what F2. See, this one didn't give us any factors. We are using our own factors. So it's F1 to F4. Then we use what 10 and 12. That's for the 10 and 12 for indirect cost. Then 1 to 4 for what the direct cost, right? That's how we evaluate them. Right. Yeah, so that's for this question, right? So that one they ask us to calculate for the total capital what investment, right? So now, basically, to read the graphs, we go through the same approach to get the total capital investment, right, for the equipment, right, so that we can be able to solve for everything that we do, right. And in economics, you have something that we also call the total production cost, right. So the total production cost (TPC) consists of what you call the manufacturing, right. Consists of the manufacturing, right. So the manufacturing relates to directly to what everything that it relates to directly to the product that we are producing, right? Then we have what you call the general expenses, right? The general expenses, right, it consists of the plant overhead, like plant overhead, right? Because of the plant overhead, you can have the administrative, right? So the administrative side too, right? And the manufacturing cost consists of what you call the fixed, right? Fixed operating cost, right? So fixed operating costs, right? Then we have the variable operating cost, right? So over here you can have something like the labor or the salary, so that we can have everything there.